had a request to walk through a couple of derivative practice problems. So I'm going to do these couple. So number one, the first thing you look at when you see a problem, you ask yourself, is it a product or is it a quotient? Now this problem is a quotient because I can see that I have a numerator over a denominator. So I'm going to use a quotient rule. Now the quotient rule says you do the denominator or low, d high, or the derivative of the numerator. So I bring the 3 in the front, 24x squared minus 8x. So low, d high, minus high, so that's the numerator, d low. So that's the derivative of the denominator. So it's x to the 1/2. So I'll bring the 1/2 in the front, x, subtract 1. So it's negative 1/2. And it's all over the square of what's below. So at this point, I'm done with the calculus. Now I have to do some simplification. And you know what? I'm not going to do too much here. I could spend forever simplifying this beast. You know what I might do is I might just use my rules of exponents. Like this is x to the 1/2, 24x squared minus 8x. And then this is 8x cubed minus 4x squared. And then it's 1/2 x to the negative 1/2 all over square root of x squared is just x. So let's use rules of exponents, okay? So we get 24, and when the base is the same, you add the exponents. So I get 2.5, which is 5/2, minus 8. This is x to the 1 power. So 1 plus 1/2 is 3/2. Oh, 8x, sorry. And then it's minus, so now I have 1/2 of 8 is 4, and 3 minus 1/2 is 2.5, which is 5/2. And then 1/2 of, now that's distributing the negative. I almost made the mistake. So it's a negative 4, but then a negative times a negative, there'll be a positive 2. And then x squared, then 2 minus 1/2 is 1 and 1/2, which is 3/2. Okay, and then that's all over x. So if I continue then, this is just algebra combining like terms. So I end up with 20x to the 5/2. I can't believe I kept forgetting to write that x. And then it's minus 6x to the 3/2 all over x. I could even simplify more because I noticed that there's an x in common. Like if I take out an x 2/2, I end up with 20x 3/2 minus 6x 1/2. Do you see that? And that's all over because it's x to the 1, which is the same as 2/2. So actually that would be the best simplified answer. Yikes. That's more algebra than calculus, to be honest. Number 2, the hardest thing about 2 is if you understand when a trig function is raised to an exponent. Do you know that this is the same thing as this? Tangent square root of x to the 3rd power. Do you guys know that? Because they place the 3 here so that you're not confused what's being cubed. Okay, now I'm going to take the derivative. Now this is not a product. I'm not multiplying two factors. It's not a quotient. So I have to take its derivative. But when I look at this, I notice that it is a composite function. There are actually 3 parts. There's the cube. So I'm going to bring the 3 in the front, leave the inside the same, subtract 1 squared. Now I have to take times the derivative of the next piece. So I take the derivative of the outside. So what's derivative of tangent? Secant squared. But the inside stays the same. And then last of all, I take the derivative of the inside. So that's x to the 1/2. So that would be 1/2 x to the negative 1/2. So I end up with, write this as a fraction. So I have 3/2. And then I have tangent of the square root of x squared times secant squared, square root of x, all over 2x square root of x. Okay? And just so you know, this means the same thing as that. Walaloo.